Okay. Good morning, students. Good morning to everyone. Okay. Um, so yesterday I gave some of the practice problem. Whether you got the answer for the practice problem? Anybody tried? I think I gave only two problems are practice problem. So remaining I gave. I think I gave. This is a sorry. This is the first problem I gave. Summation alpha beta by gamma. Okay. So this is the first problem I gave. The answer is 2pr minus q square by r. So this is the answer for the first problem. So either you can follow this method. So in this method, they first write alpha beta by gamma, and then beta gamma by alpha, and then gamma alpha by beta, and then multiply and divide by here gamma, here alpha, here beta, and then take commonly alpha beta gamma. So then you have the remaining is what? 1 by alpha square plus 1 by beta square, 1 by gamma square. That is a summation of 1 by alpha square. So alpha beta gamma we know already, that is minus r. Okay, and the summation 1 by alpha square, that is a subdivision number 6. Okay, subdivision number 6 is the summation 1 by alpha square. So we have that result. So using that result you can do. Otherwise, directly you can do you can take alpha beta gamma as LCM. If you take alpha beta gamma as LCM, the numerator you have what? The numerator you have alpha square beta square, okay, plus beta square gamma square plus gamma square alpha square. The numerator is a summation of alpha square beta square divided by alpha beta gamma. Okay, so summation of alpha square beta square, whether we have, yes, that is q square minus 2rp, q square minus 2rp divided by minus r. Okay, so because of this minus r, they wrote 2pr minus q square by r. So you can do in any method. Summation alpha power 4. So they are using alpha square plus beta square plus gamma square whole square. Okay, okay, and then minus 2ab minus 2bc minus 2ca. So they are subtracted here. So this is what? This is actually what? Summation alpha square whole square. This is what? Summation alpha square whole square. This is minus 2 into summation alpha square beta square. So for these two expressions already you have the answer subdivision 3 and 5. Okay, substitute those expressions here and simplify and get the answer. Okay, and then I posted this 10 problem. If you have any doubts, you can ask me. Otherwise, I will go to the next section. But here the explanation is not that much level. So you need to, they gave directly everything. So you need to write a step by step, and then if you do as we discussed in the previous class, you can easily get it.
Sir,
yeah, please tell.
sir, can you please explain the fifth subdivision?
Fifth subdivision. Okay, I am expecting the same. Okay, Paritosh, because yesterday I am also a little bit struggled fifth subdivision to understand. Okay, I will explain you, Paritosh. Okay. Summation alpha square, but if you write like this, you can easily get it. But okay, but again, yes, I will explain here. Maybe I will explain here. Okay, so please tell problem number 5. Problem number 5 is summation alpha square beta gamma. Okay. So summation alpha square beta gamma means totally how many terms? First you should fix alpha square. Okay, beta gamma. Okay, plus alpha square because it has 4 roots. Beta delta. Okay, and then the other possibility is what? Alpha square gamma delta. Okay, wow. So alpha, beta, gamma, delta. So I fix alpha square, and then remaining there are 2 positions. Okay, wow. There are 3 positions. Always here you have alpha square. Always here the first position is alpha square. Okay, out of remaining 3, so I need to choose 2. Okay, well, I need to choose 2. So 3C2. Okay, so 3 ways. So 1, 2, 3. Okay, so plus similarly fix the beta square here. Okay, if you fix beta square, alpha beta square gamma. Okay, and then fix beta square okay alpha and delta plus again fix beta square and beta and gamma and delta. Okay, gamma and delta. So I will write beta square gamma delta. Beta square gamma delta. Okay, so similarly you should write next alpha beta gamma square. Here I am fixing gamma square plus alpha gamma square delta. Okay, and then beta gamma square delta. Okay. And then last I fix delta square alpha beta delta square plus alpha gamma delta square plus beta gamma delta square. Okay. So totally 12 terms. Okay, you have here. So here so anyway I need to express this is in terms of S1, S2, S3, S4. Okay. So any of the combination, maybe I can use these 2 or these 3. Okay, so there is no need to use all the 4s. Okay, so out of these 4 I need to either I can use 3 or 2. Okay, so combination, this is depending upon the expressions. Okay, so here I will take directly S1 alpha plus beta plus gamma, and then S3. And why I'm choosing S3 means here have 3 terms alpha square beta gamma. So that's why I'll choose S3. What is S3 means here? S3 means we have 4 roots. Out of 4 you can choose 3. 4C3 is a 4. So 4 terms you have. So alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. So there are 4. This is actually S3. The roots taken 3 at a time. Okay, out of 4 you are choosing 3. So if you multiply these 2, you will get what? Alpha square beta gamma. That is the first term. If I multiply these 2, alpha square beta delta, second term. If I multiply these 2, alpha square gamma delta, third term. If I multiply these, I don't have anything. So I need to subtract. So minus alpha beta gamma delta. Similarly, if I multiply beta into this, alpha beta square gamma, first term. Alpha beta square delta, second term. And then alpha beta gamma delta, I don't have, minus alpha beta gamma delta. And then beta square gamma delta. Similarly, next, I think here, I missed what? Alpha plus beta plus gamma plus delta. Okay, because we have 4 roots. Okay, similarly, gamma into, you should multiply everything. So, first, if I multiply these two, you'll get alpha beta gamma square. And then alpha beta gamma delta, I don't have, so minus alpha beta gamma delta. And then alpha gamma square delta. And then beta gamma square delta. So similarly, if you take delta, the first term itself, alpha beta gamma delta, I don't have. So remaining everything, you can check it easily. Alpha beta delta square, and then alpha gamma delta square, and then beta gamma delta square. So from this, you can easily write now summation alpha square beta gamma is equal to summation alpha. This is what? Summation alpha beta gamma. Okay, this is summation alpha beta gamma minus 4 times alpha beta gamma delta. So what is the summation alpha, Paritosh? Minus P.
Minus P.
Yeah, and then what is S3?
Minus R.
Minus R. What is S4?
S.
Yes. So PR minus 4S. Is it correct?
Yes, sir.
Okay.
Thank you, sir.
Okay, welcome, Paritosh. Okay. And then, okay, you can try. Okay, if you try, if you have any doubts, okay, you can ask me in the next class also, no problem. So, but first you should work out. Then only you know that where you struck. Okay. So now, if there is no other doubts, then I will move to the next topic. So Descartes' rule of sign. Okay. Descartes' rule of signs. Okay. So here, using Descartes' rule of sign, we will find the number of imaginary roots. Okay, number of imaginary roots, number of. Okay. So first I will explain you the Descartes' rule of sign. The maximum, the first one, the maximum number of positive roots of f of x is equal to 0, okay, does not exceed the number of sign changes in f of x is equal to 0. Again, I will repeat. The maximum number of positive roots, it's a maximum, okay, maximum number of positive roots of f of x is equal to 0 does not exceed the number of sign changes in f of x is equal to 0. Sign changes means the coefficients, okay, the coefficients of f of x. Okay. Similarly, next one, the maximum number of negative roots does not exceed the number of sign changes in f of minus x is equal to 0. So you should know these two rule. So the first problem is show that the equation x power 7 plus 5x power 6 minus, please write down in your notebook, plus 5x power 6 minus x cube plus 7x plus 2 equal to 0 has at least 2 imaginary roots. Okay. So first, let us take f of x, this is the equation x power 7 plus 5x power 6 minus x cube plus 7x plus 2 equal to 0. Okay, the sign in f of x. Okay, what is the coefficient of, here you have plus and then minus. So I don't have x power 4 term. Okay, you can leave it. Okay, plus minus, and then I don't have x square term, and then I have x term plus. So the sign change positive to negative. So there is one sign change from negative to positive. There is one more. So there are two sign changes. So here there are two changes of signs. Thus the equation has at most two positive roots. And then next, signs in f of minus x is equal to 0. Just replace x by minus x in the given equation. Okay, so if you replace like this, you will get f of minus x is equal to this equation. And then write the sign minus, plus, minus, plus. Now the sign changes is minus 2 plus 1, plus 2 minus 1, minus 2 plus 1. So there are three sign changes. So here there are three changes of sign. Hence the equation has at most three negative roots. So already I told that the equation has at most two positive roots. Now it has at most three negative roots, but the degree is what? 7. So it has at least two imaginary roots. So f of x is equal to 0 has at least two roots of complex. Okay. So the next topic is a stability analysis. Okay. So I will explain first the concepts. Suppose if you have any doubts, then I will use this open board and then I will explain you. Okay. So the stability analysis, I think electrical students, electrical means I think EEE, ECE and E&I students will study this stability analysis in the third semester. I think we'll study in the third semester. But this is something as an application part. Okay, application of theory of equations. Okay. So now I will give some introduction. First, so stability analysis, Routh-Hurwitz criterion. The Routh-Hurwitz stability criteria is an analytical procedure for determining whether all the roots of polynomial have negative real part or not. Okay, so this is the whole content of this analysis. Okay, so the first two lines, the root is a stability criterion is an analytical procedure for determining whether all the roots of polynomial have negative real part or not. Okay, so why they are question is why they are concentrated on the negative real part. So there is a connection. Okay, so for this I will tell you in the end of this slide. So there is some connection between the why we are considering negative real part. Okay, and I also will send a book. Okay, so that book it is more elaborately they discussed. Okay, so now the first step in analyzing the stability of system is to examine its characteristic equation. Okay, so the transfer function, okay, P of S is a transfer function. So it can be written by N of S by D of S. And the denominator, the D of S is called a characteristic equation. Okay, the first step in analyzing the stability of the system is to examine its characteristic equation, that is a D of S. The necessary condition for stability is that all the coefficient of the polynomial be positive. So that is the necessary condition. Okay. So what happened if some of them are negative or zero? Okay. If some of the coefficients are zero or negative, it can be concluded that the system is not stable. So you can immediately tell if some of the coefficients are zero or negative, the system is not stable. So you may ask, sir, suppose if all the coefficients are positive, can we conclude that the system is stable? No. So that you can't conclude. So that is only the necessary condition. It is not sufficient condition. Okay. So next line, when all the coefficients are positive, the system is not necessarily stable. Even though the coefficients are positive, some of the roots may lie on the right half of the S plane or on the imaginary axis. So we are, suppose if all the roots are lying in the negative, all the roots of the polynomial have negative real part, then it is stable. Okay. So here again I'll read. When all the coefficients are positive, the system is not necessarily stable. Even though the coefficients are positive, some of the roots may lie on the right half of the S plane or on the imaginary axis. In order for all the roots have negative real part, it is necessary but not sufficient that all the coefficients of characteristic equation be positive. Okay. So if all the coefficients of the characteristic equations are positive, then the system may be stable, and one should proceed further to examine the sufficient condition of stability. So here Hurwitz and Ruth independently published the method of investigating the sufficient condition of stability of a system. The Ruth-Hurwitz criterion is in terms of determinants. Okay, is in terms of determinants, and the Ruth criterion is in terms of array formulation. So the Ruth stability criterion is presented here. So the Ruth stability criterion is based on ordering the coefficients of the characteristic equation into a schedule called the Ruth array as shown below. So this is the given polynomial where a0 is greater than positive, a0 is positive. S power n. In S power n, you should write the coefficient of a0, and then a2, and then a4, and then a6, and then a8, and so on. And Sn minus 1, you should write a1, a3, a5, a7, a9, and so on. Okay. So remaining Sn minus 2, Sn minus 3, how to find out, I will tell little bit later. First two rows you can write from the given polynomial. So you should go up to S power 1, S0. Okay. The Ruth stability criterion can be stated as follows. So this is the necessary and sufficient condition. So the necessary and the sufficient condition for stability is that all the elements in the first column of the Ruth array be positive. So what is the first column? So this is the first column. This is the first column. Okay, it should be positive. So that is the necessary and sufficient condition. If this condition is not met, the system is unstable. You can tell the system is unstable. and the number of sign changes in the elements, that is in the first column. Okay, the number of sign changes in the elements of the first column of the root array corresponds to the number of roots of the characteristic equation in the right half of the S-plane. So this is an important condition, and then this note explains the order of sign changes in the first column is, suppose if you have plus, plus, minus, plus, and plus, then plus 2 minus is considered one sign change, and the minus 2 plus is considered another sign change. Okay, construction of root array. So let the characteristic polynomial be, this is the characteristic polynomial. The coefficient of the polynomial are arranged in 2 rows as shown below. So s power n. So you should write a0, a2, a4, a6, and so on. S power n minus 1, a1, a3, a5, a7, and so on. Suppose when n is even, s power nth row is formed by coefficient of even terms. Okay, and the s power n minus 1 row is formed by the coefficient of odd terms. Okay, suppose when n is odd, s power n row is formed by the coefficient of odd terms, and s power n minus 1 row is formed by the coefficient of even terms. Okay, the other rows of root array up to s power 0 row can be formed by the following procedure. Each row of root array is constructed by using the elements of the this is also important point. Each row of root array is constructed by using the elements of the previous 2 rows. Okay, so here it is considered any two consecutive rows of root array as shown below. So these s power, okay, s power n minus x, this is s power n minus x minus 1. Okay, so x0, x1, x2, x3, x4, x5. Here y0, y1, y2, y3, y4, y5. So let the next row be, next row on the s power n minus 1, n minus x minus 2. Okay, so z0, z1, z2, z3, z4. So how to find z0? How to find z1? So z0. So let just see here. All z0, z1, z2, z3, z4. Okay. Actually, this is z0, z1, z2, z3, z4. The denominator is what? You can see here. y0. That is fixed. y0 is this element. Okay. In the second row you have okay, this is y0. And the first column, you see the first column in everything, that is x0, y0. So x0, y0. Okay, only the change in the second column. Okay, the z0 you have x1, y1. Okay, in z1 x2, y2. z2 x3, y3. Similarly, z3 x4, y4. And then here you have minus 1 common. So usually when we are doing determinant, okay, what you will do? Determinant of 2 by 2 matrix. Okay, x0, y1 and minus x1, y0. But here have minus. So z0 equal to is what? y0 x1 minus y1 x0 divided by y0. Similarly, z1. So expand this determinant and then multiply by minus 1. So this is the procedure to find z0, z1, z2, z3, z4. Okay. So the elements z0, z1, z2, z3, z4 are computed for all possible computation as shown above. In the process of constructing root array, the missing terms are considered as 0. Suppose if x cube term is missing or x square term is missing, then it should take considered as 0. Also, all the elements of any row can be multiplied or divided by a positive constant to simplify the computational work. Okay, so this is also a point you should note down. Okay, all the elements of any row can be multiplied or divided by a positive constant to simplify the computational work. Okay. In the construction of root array, one may come across the following 3 cases. First, case 1, normal root array. Okay, that is a non-zero elements in the first column of root array. Case 2, a row of all 0. So all the elements in that row is 0. That is case 2. Case 3, first element of a row is 0, but some or other elements are not 0. So there are 3 cases. Case 1, normal root array. In this case, there is no difficulty in forming root array. The root array can be constructed as explained above. The sign changes are noted to find the number of roots lying on the right half of the S-plane, and the stability of the system can be estimated. In this case, if there is no sign change in the first column of root array, then all the roots are lying on the left half of the S-plane and the system is stable. If there is sign change in the first column of root array, then the system is unstable and the number of roots lying on the right half of the S-plane is equal to the number of sign changes. The remaining roots are lying on the left half of the S-plane. Okay. Case 2, a row of all zeros. Okay, so you should concentrate little bit this one, a row of all 0. And all 0 row indicates the existence of even polynomial as a factor of the given characteristic equation. In an even polynomial, the exponent of s, the exponents of s are even integers or 0 only. So you should note down. Okay, all 0 rows indicates the existence of even polynomial as a factor of the given characteristic equation. In an even polynomial, the exponents of s are even integers or 0 only. This even polynomial factor is also called auxiliary polynomial. The coefficient of auxiliary polynomial will always be the elements of the row directly above the row of zeros in the array. So this point also you should remember. Okay, so again I'll repeat the last one. The coefficient of the auxiliary polynomial will always be the elements of the row directly above the row of zeros in the array. So if you solve the problem, then you can understand. Suppose if you don't understand now, okay. Okay. The roots of an even polynomial. So as already I told that even polynomial as a factor of the given characteristic equation. Now we are discussing the roots of the even polynomial. The roots of an even polynomial occur in pairs that are equal in magnitude and opposite in sign. Hence, these roots can be purely imaginary purely real or complex. Okay, the purely imaginary and the purely real roots occur in pairs. So you can see in the diagram. Okay, if you see this diagram, okay, this is purely real. Okay, purely this is purely imaginary. Okay, the roots of even polynomial occur in pairs that are equal in magnitude and opposite in sign. Hence, these roots be purely imaginary. So imaginary, first diagram, purely real, okay, or complex. So the purely imaginary or purely real, okay, roots occur in pairs. You can see in the first two diagram. The complex roots occur in group of four. Group of third diagram, group of four, and the complex roots have quadrantal symmetry. So that is the quadrantal symmetry means that is the roots are symmetrical with respect to both x and y axis, both real and imaginary axis. So that is the third diagram. So in the figure 4.1 it is explained, shows the roots of an even polynomial. And then case 3. Case 3 is the first element of a row is 0. Okay, that is case 3. You can see here. Case 3 is what? First element of a row is 0, but for some or other elements are not 0. That is case 3. So while constructing root array, if a 0 is encountered as the first element of a row, then all the elements of the next row will be infinite, because you can see here in the construction, okay, suppose y0 is 0, in the next row you are using y0, that is in the denominator, so you will get in the next row everything is infinity. Okay, so to avoid this, so while constructing root array, if a 0 is encountered as first element of a row, then all the elements of the next row will be infinite. To overcome this problem, instead of 0, I will replace by epsilon. Okay, and complete the construction of array in the usual way. So in the usual way means as in the case of case 1. Finally, allow epsilon tends to 0 and determine the values of elements of array, okay, of the array which are functions of epsilon. Okay, so note, so this is an important note. If all the elements of a row are 0, then the solution is attempted by considering the polynomial as the case of case 2. Okay, suppose even if there is a single row, single element 0 in x power n, s power 1 means what? S power 1, you can see here, s power 1. Yes. Suppose if you have single 0, so you don't consider that is the case 3. You should consider that is the case 2. So all the elements are 0. So okay. So that is a note. Important note, because suppose if we have 0, so you may think we have only 1 0. So we proceed by case 3? No, you can't do like this. So you should consider it is a row of all 0 because it contains only one element. Okay, sorry. Yeah, note, if, okay, here, even if there is a single element 0 on s power 1 row, it is considered as as a row of all 0. Okay. So here there are three sub A, B, C. This is actually summary of what we discussed in the last 15 minutes. Okay. If there is no sign change, in the first column of route array, and if there is no row with all zeros, then all the roots are lying on the left half of this plane and the system is stable. Okay. If there is sign changes in the first column of route array and there is no row with all zeros, then some of the roots are lying on the right half of the S-plane and the system is unstable. The number of roots lying on the right half of S-plane is equal to number of sign changes, and the remaining roots are lying on the left half of the S-plane. Third point, if there is a row of all 0, after allowing epsilon tends to 0, then there is a possibility of roots on imaginary axis. Determine the auxiliary polynomial and divide the characteristic equation by auxiliary polynomial to eliminate the imaginary roots. Okay. So now I'll move to the example 1. Please write down this question. Okay. Please write down this question. Using route criterion, determine the stability of the system represented by the characteristic equation s power 4 plus 8s cube plus 18s square, this is s square, plus 16s plus 5 is equal to 0. Comment on the location of the roots of the characteristic equation. Okay. So this is the given characteristic equation. Okay, this is the given characteristic equation. Okay. So what is the first step? Please tell. What is the first step? Okay. So what is the first step?
Sir, we have to write A0, A2.
Kavimani, okay. Yeah. So please tell what is actually the given characteristic equation is what? The given characteristic equation is fourth order equation, and it has how many roots? 4 roots. Since the highest power of S is even number, so the first row of route array using the coefficient of even powers of S, and form the second row using the coefficients of odd powers of S. Okay, va? So S power 4 என்னென்ன இருக்கும் coefficients 1, 18, okay, coefficient of S power 4, and then coefficient of S square, and then constant term 1, 18, 5, and then coefficient of, that is the first row. S power 3 you have what? 8 and 16. 8 and 16, row 2. Now you need to find out the row 3. Row 3 is S power 2. Do it and tell the elements in the next row, third row. Just I want to know how many of them understand this concept. That's why I'm asking a question. So try to give your answer. What is the elements in the third row?
Sir, first element 18, sir.
Purna Chandra,
First element 16, sir.
first element is 16. I will check it. Yeah, first element is 16. What about second element? Please write. Hello, Pragadish. Good morning, Pragadish. Okay, Purna Chandra, I think you told 16.
Sir.
Yeah, 16 and then
10.
16, 10, 10 of 5.
Sir.
16 and 5. 16 and 5 is correct answer. Okay, I will tell you. Okay, how to calculate the next row. Okay, so I will write here rough calculation. You can tell what is s power 4.
Sir,
Please tell.
second element 10, sir.
No,
Not 5, sir.
s power 4. Please tell s power 4 coefficient
1.
1.
1 in 5.
185. Here
15.
15.
Sir, 118 and 5.
118 and 5. Okay, 118
118
and
and
5. Second row
8.
8.
18.
16.
16. Yes, sir, 16, sir.
118, 5 and 8 and 16. Okay, 8 and 16. So actually here 8 and 16, instead of 8 and 16 you can write what? 1 and 2. Okay, I already told that you can divide or multiply elements of a row by a positive number. Okay, so now I need to find S2. Okay, I need to find this element and okay, first you should multiply 1 into 18 minus 1 into 2, 1 into 2 divided by this one. Okay, why not? So is equal to 18 minus 2 divided by 1, that is 16. You consider this is 0. You should consider this is what? 0. Okay, so if you multiply these two, 2 into 5 minus 0, 18 into 0 divided by this 1. So this is actually what? 10. 10.
No, sir, we have to keep the first column same, sir.
Yes,
So
yes,
it
you are
should
right.
be 0 into 1 minus.
Yeah, you are right, Pantush. Sorry. So actually, first column we need to fix it. Okay, yes. 1 into 5. 1 into 5 minus 1 into 5 minus 1 into 0. I think I am also doing the same mistake what Purnachandra done it. Okay, so divided by 1. Okay, divided by 1. So 5. Okay, 16 and 5. So in this way, we got s power 2. How to get s power 1? S power 1 is what? 16 into 2, 16 into 2 minus 1 into
minus
5, 1 into 5 divided by
16.
16. So this is what? 32 minus 5 divided by 16. So 27 by 16. So you can see here. Yeah, 27 by 16 is 1.7. Using calculator, do it.
1.68, sir.
1.68, 1.7 வச்சிருக்காங்க. ஓகேவா?
Yes.
Thank you, Prithvirmohan. So, or you can keep 27 by 16, okay? And then s power 0, one more thing. So you should keep this is 0, okay? So you need to multiply first 1.7 into 5 minus 16 into 0 divided by 1.7. So you'll get 5. So this is the first column. So in the first column, all the elements are what? Positive. Okay. So then you can conclude that the system is stable. So that is explained here. I'll show you. So the calculation is they done it here. I think we got 1, 1, 16, 1.75. This is column 1. Okay. On examining the elements of first column of route array, it is observed that all the elements are positive, okay, and there is no sign change. Hence, all the roots are lying on the left half of S plane and the system is stable. So this is comes under case 1. Okay. So result is stable system. All the 4 roots, because this is the 4th degree equation, all the 4 roots are lying on the left half of S plane. Okay. So now I'll move to the problem number 2. Okay. Problem 2. Construct route array and determine the stability of the system, okay, whose characteristic equation is, I will tell, you can write s power 6 plus 2 s power 5 plus 8 s power 4 plus 12 s cube plus 20 s square plus 16s plus 16 is equal to 0. Also determine the number of roots lying on the right half of S plane, left half of S plane, and on imaginary axis. Okay. So first you should write the characteristic equation. The characteristic equation system is the given equation: s power 6 plus 2s power 5 plus 8s power 4 plus 20s square, 20s square plus 16s plus 16 equal to 0. So first s power 6, first row. The first row you have what? The first row you should write 1,
1, 8,
8,
20, 16.
20 and 16. The second row
2,
2,
12,
12,
16.
Okay. So next this is s power 6 and then s power 5. Row 1, row 2 are over. Okay. And then row 3. What is row 3? Please tell. Similarly, do it. Uh, 12 minus 16. 12 minus 16 divided by not 12. Sorry, 16 minus 12. 16 minus 12. 4 by 2.
2, sir.
2. Okay, 2. And then 40 minus 16. 40 minus 16 is what?
12, sir.
24 by 2, 12.
4 by 2, 12. Okay, consider this is 0. Okay, 32 divided by 2, 16. So you have 2, 12 and 16. Is it correct?
Yes, sir.
So instead of 2, 12, 16, you can write what?
168.
168.
168. Divide throughout by 2. Okay. So first row, 1. First row and second row, it is the same. And then third row, that is s power fourth row, 1, 6, 8. Okay, va? But next s power third row, because s power 5 and s power row are same. If it is same, that is row 2 and row 3 are same, okay, then the next row should be 0. All the elements are 0. Okay. So if all the elements are 0, then here you can see here. So you should form the auxiliary equation, because s power third 3 row is 0, 0. Then I need to form the auxiliary equation, that is A. Okay. So above this you have what? 1, 6, 8. I told that the auxiliary equation of even degree, and the exponents are what? Powers of exponent is what? Even or 0. So you should write 1 into s power 4 plus 6 into s square plus 8. So that is s power 4 plus 6s square plus 8. Okay, now you need to differentiate this equation with respect to s. So dA by ds. If you differentiate, you will get what? 4s cube plus 12s. Now, the coefficient of dA by ds are used to form s power 3 row. Okay, so s power 3 is what now? 4 and 12. Or throughout divide by 4, you can write 1 and 3. So the next row is 1 and 3. Okay, this is actually the next row. So now s power 2 row. So you can use s power 4 and s power 3, and please check it whether you are getting 3 and 8. That is, you need to multiply what? 6 1 into 6.
1 by
6.
3, sir.
1 into 6, 6 minus 3, 3 divided by 1. So 3. Okay. So next here 0. Okay. 1 into 8. Okay. Minus 1 into 0. So 8 by 1, 8. I think I got it 3 and 8. Okay. Once you got s power 2, next you should move to s power 1. So s power 1, how to calculate s power 1? 3 into 3, 9, minus 1 into 8. So 9 minus 8,
1 by 3,
1,
sir.
yeah, by 3. So that is 1 by 3. 1 by 3 is 0.33. Okay. So next s power 0. So s power 0, you consider this is 0. So multiply these two. Okay, 1 by 3 into 8 minus 3 into 0 divided by 1 by 3. So you'll get 8.
8, sir.
8. So only the problem is you can face the problem only if you have all the rows are 0. If you have all the rows are 0, first you should write the auxiliary equation. That is just above you have 1, 6, 8. Here you see that s power 4. So the maximum is s power 4 and the coefficient is 1. So next 6 into s square plus 8. And then differentiate this equation with respect to s. Okay, you'll get a 4s cube plus 12s, and then take that coefficient, okay, 4 and 12. So here you can commonly have divide by 4, so 1 and 3, that is 1 and 3. Okay, so now I'll come to the final part. So consider this column 1. On examining the elements of first column of Routh array, it is observed that there is no sign change. There is no sign change. So the row with all zeros indicates, the rows with all zeros indicates the possibility of roots on imaginary axis. Hence, the system is limitedly or marginally stable. Okay. The auxiliary polynomial. What is the auxiliary polynomial? S power 4 plus 6s square plus 8. So you need to find the 4 roots of this equation. So take x square equal to x. You'll get a quadratic equation in x. So if you solve this quadratic equation x, you'll get 2 roots. So minus 2, minus 4. But we know that x is what? S square. So s square equal to minus 2, x square equal to minus 4. Then s is equal to plus or minus I root 2 and s is equal to plus or minus I2. So instead of I, they are using j here. So you have 4 roots. Plus j root 2 minus j root 2 plus third one is plus j2 or 2j and then minus j2. So the roots of the auxiliary polynomial, the roots, again, okay, this is an important point. The roots of auxiliary polynomial, that is these 4 roots, are also the roots of the characteristic equation, that is a given equation. So hence, 4 roots are lying on the imaginary axis and the remaining 2 roots, because this is the 6th degree equation. This is the 6th degree equation. So 4 roots are lying on the imaginary axis and there is no sign change. So if there is a sign change, then there is a possibility on the right half of the S-plane. There is no sign change and the 4 roots are lying on the imaginary axis. So the remaining 2 roots should lie on the left half of the S-plane. So final conclusion, the system is limitedly or marginally stable. The reason is we have imaginary roots. Okay. So why we have the imaginary roots? We have a row of all 0. So that's why the possibility of imaginary roots. Okay. And okay, second point, 4 roots are lying on the imaginary axis and the remaining 2 roots are lying on the left half of S-plane. And then last problem, so I try to finish it because tomorrow I don't have the class. If I start from Friday, then you will forget these concepts, then it is very difficult to explain all the concepts again. So now you know something, if you understand the concept, okay, then I'll try to finish. This is the last problem. Construct the Routh array and determine the stability of the system represented by the characteristic equation s power 5 plus s power 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. Comment on the location of the roots of the characteristic equation. So this is a given equation, power is 5. Okay. So in s power 5, you should write what? 1, 2, 3. Okay. And then s power 4, 1, 2, 5. So you know how to write the remaining rows, s power 3. Okay. Okay. In s power 3, I have 0 here. I have 0 here. Okay. So then you need to replace 0 by epsilon. Okay. That is row 3. So once you replace epsilon, then as usual, you need to proceed further. Okay. Using S4 and using S3, you should form S square. Okay. So you need to perform. You should go up to s power 0. You should try this. If you have any difficulty to form this row, you can ask me in the next class. Okay, once you finished all the rows, s power 5, s power 4, s power 3, s square, s power 1, s power 0, the calculation is here. Okay, so and then you need to allow epsilon goes to 0. So again, you need to write s power 5, again, that is 1, 2, 3, first row, s power 4 is what? 1, 2, 5. S power 3 is what? S power 3 is 0, minus 2, S power 2 is infinity, because here have denominator is epsilon, so infinity, and then 5. S power 1 is what? S power 1 is 0, 0. Here also 0. So minus 4 by 2, minus 2. Minus 2. And S power 0 is 5. Okay, here how many sign changes? You can see here plus 1, minus 2. Plus 1 to minus 2, you have one sign change. From minus 2 to plus 5, there is one more sign change. So there are two sign changes. On observing the elements of the first column of route array, it is found that there are two sign changes. Hence, two roots are lying on the right half of S-plane and the system is unstable. The remaining three roots, because the given equation is polynomial of degree 5, the remaining three roots are lying on the left half of S-plane. The conclusion or result, the system is unstable. Two roots are lying on the right half of S-plane and three roots are lying on the left half of S-plane. Some of the part A questions, okay. So I will give quickly. So what is the characteristic equation? Okay, the denominator polynomial of that is R of S. Okay, so C of S by R of S. Okay, the denominator polynomial R of S is called characteristic equation of the system. How the roots of the characteristic equation are related to stability. So this is somewhat important question. How the roots of characteristic equations are related to stability. If the roots of the characteristic equations have positive real part, then the impulse response of the system is not bounded. Okay, the impulse response will be infinite as t goes to infinity. Hence, the system is will be unstable. So, if the roots have negative real part, then the impulse response is bounded. So, that is the impulse response becomes 0 when t approaches infinity. Hence, the system will be stable. That's why we are looking for the negative real part of the roots. What is the necessary condition for stability? Necessary condition for stability is that all the coefficients of the characteristic polynomial must be positive. What is the relation between stability and the coefficient of the characteristic polynomial? If the coefficient of the characteristic polynomial are negative or 0, then some of the roots lie on the right half of the S-plane. Hence, the system is unstable. If the coefficients of characteristic polynomial are positive, and if no coefficients are 0, then there is a possibility of the system to be stable, provided all the roots are lying on the left half of S-plane. What is the necessary and sufficient condition for stability? The necessary and sufficient condition for stability is that all the elements of first column of route array should be positive. That is, you know that. What is route criterion? Okay, already I explained this. Okay, what is auxiliary polynomial? Okay, so this is also I explained. In the construction of route array, a row of all 0 indicates the existence of even polynomial as a factor of the given characteristic equation. So in an even polynomial, I already explained, the exponents of S are even integer or 0. Okay, in one of the problem we have S power 4 plus 6s square plus 1 something we have. So this even polynomial factor is also called the auxiliary polynomial. The coefficient of auxiliary polynomial are given by the elements of the row just above the row of all 0. Okay, So I explained, okay. Suppose if you have any doubts, you can ask me in the next class. It's on Friday. So, and in your book, please check in your book the theory of equation. You have the stability analysis, but you should carefully read. Again, I saw that some of the printing mistakes in some of the problems, so you should be read carefully and try to solve the example problems first in your Virarajan book, and then exercise problem. And then I will send you one book that is useful for you, for especially SEEE students for next semester, third semester also. Okay. Theory of equations. Yes. Control system engineered by Nagorhani. Yes. So this is the book I will send you. Okay, in this book, fourth chapter. Yes. So just here I explained only 50% from the book. If you are interested, please go through. Okay, please go through from the beginning and understand. So concepts of stability and the root locus. Okay, so from this book only, so I took the material. But some part you can understand now, maybe you won't understand remaining thing. So keep this book, it may be useful for you later. So Ruth Hurwitz theorem, okay. This is the construction. Case 1, case 2, case 3. So in case 2, we saw this diagram. Okay. And there are one more method is also, it is, I explained here how to get the, in case, from the auxiliary polynomial, okay, I told that it will differentiate, okay, that is method 1. Method 2 is also there. So divide the characteristic equation by auxiliary polynomial. So I don't suggest that method. If you want, you can read and understand. So here the first problem, but in this book, nearly 10 problems are there. Okay, so I explained only 3 problems in each case. So if you are interested, please go through the remaining problems. 4.3, 4.4, 4.5, 4.6. So at least to try to solve some of the basic problems. .9, but I'm not going to deeper. So those who are interested, please go through this book. only the 4th chapter up to page number 4.1 to 4.26. So 25, 26 pages. I will send through WhatsApp. Okay. So thank you everyone. So the next class, I will start binomial series. Binomial, still we have in the 3rd unit, binomial, exponential, and then logarithmic series. Okay.
Sir, in Virarajan book, theory of equations is there, sir.
Yeah, Virarajan, the scanned copy. The scanned copy.
Which you send in WhatsApp, sir.
Yeah, WhatsApp. Through WhatsApp, I send it.
Okay, sir. Okay, sir.
But in that scanned copy, I think the stability analysis is not there. I think so. Okay, please check it.
It's lightly
Sir,
there,
it is
sir.
there, sir.
It is there.
Yes, sir.
Okay.
Okay.
But this much allowability not there, sir.
Sorry.
Only introduction they have given briefly, sir.
Yes.
That's all.
That's why I used this book.
Okay.
Okay.
Sir.
So
Okay.
please go through this book if you are interested. So please go through. Okay.
Okay.
You'll understand a little bit more. Okay. Thank you. Thank you, everyone.